Hello everyone, welcome back to the channel. I'm Ben, your AI specialist at Botify IQ, an AI-driven company proudly collaborating with Weaviate Digital Marketing. In today's session, we're diving into the fascinating world of vector databases, what they are, why they matter, and how they're transforming the landscape of modern AI applications. Here's what we'll be diving into during this session. What is a vector database? Why vector databases are essential in the AI era. Difference between traditional databases and vector databases. How vectors represent meaning and context in AI. Real-world examples like ChatGPT, image search, and recommendation systems. Let's take a scenario here. Imagine you walk into a giant library. There are millions of books and you want to find something about ancient civilizations that lived near rivers. You could search by exact keywords like civilization or river, but what if the book used the phrase societies around water bodies instead? Traditional databases would miss that connection because they only understand exact words, not meanings. But a vector database would catch it instantly because it understands similarity in meaning, not just text matching. Which means, in simple words, the magic of vector database is they store and search data by understanding relationships and meaning rather than just keywords. In technical or technological term, the vector database is different from normal database because normal database is searched and stored by keywords and vector database is stored and searched by meanings, which is why the vector database can easily communicate with models and humans. Now let's talk about the basic idea behind a vector database and break it down. A vector database is a special kind of database designed to store, search, and compare vector embeddings, mathematical representations of data like text, images, audio, or even video, before talking about vector database. One should understand what are vectors. In mathematics, a vector is just a list of numbers like 0.2, 0.7, 0.5, 0.9. In artificial intelligence, vectors are used to represent meaning. When AI models, like GPT or BERT, process information, they convert words, sentences, or images into these numerical lists called embeddings. For example, the word king might be represented as 0.35, 0.89, 0.10, 0.55. These are numbers that represent the word king stored in the vector database for faster search. The word queen might be 0033, 090, 0009, 054. The same goes here. These are numbers that represent the word queen and stored in the vector database for faster search. These two vectors are very close to each other in mathematical space because they share similar meanings. So, a vector database stores such embeddings and helps you find the most similar ones quickly. Hope you are clear with the concept now. Let's talk about why vectors are important. Humans understand meaning intuitively. If I say a dog is an animal and a cat is an animal, you automatically know that dog and cat are related concepts. Both are pets, both have fur, both are animals. Computers, however, don't understand this naturally. They see words as symbols or strings until AI models translate these words into numerical forms that carry meaning. These numerical forms of vectors are what let AI systems to find similar meanings between words or sentences, recognize faces in images, recommend songs or products you might like, and understand your intent in a chatbot conversation. So, without vectors, AI wouldn't truly understand context or semantic similarity. Structure of a vector database. Now, how does a vector database actually work? Think of it as a warehouse that stores millions or billions of these numerical vectors. Each vector is linked to the original data, maybe a piece of text, an image, or an audio clip. When you query the database, for example, show me something similar to this image or find documents related to renewable energy, the database converts your query into a vector and then searches for the most similar vectors among everything it has stored. Let's break this structure into simple parts. First point is embedding storage. This is where the actual vector representations are stored. Each data item, a paragraph, an image, or even a customer profile, is turned into a vector and stored along with an ID or metadata. Example: text, London is the capital of the UK. Vector will convert the text to numeric value as 0.23, 0.56, 0.12, 0.28. Metadata, topic, geography, region, Europe. The second point is indexing. To find similar vectors quickly, the database uses special algorithms like HNSW, Hierarchical Navigable Small World, IVF, Inverted File Index, FAISS, Facebook AI Similarity Search. These algorithms help organize vectors in a way that allows fast similarity searches, even when there are millions of records. The third point is similarity search engine. When a new query vector comes in, the database compares it with the stored vectors using mathematical distance metrics such as cosine similarity, measures the angle between two vectors. Euclidean distance measures the straight line distance. The vectors that are closest, meaning most similar in context, are returned as results. The fourth point is metadata filtering. Sometimes you don't just want similar results. You also want to filter by specific conditions like date, location, or category. Vector databases combine semantic search, based on meaning, with structured search, based on metadata, to give powerful hybrid results. Example: let's take a simple real-world example. Suppose you have an online fashion store. You want your search system to work like this. When a customer uploads a photo of a red dress, the website should automatically show similar dresses, not just red ones, but also ones with similar patterns, fabric, or style. Traditional databases can't do that because they rely on tags like red or dress, but with a vector database, each product image is converted into a vector through an AI model. When a user uploads an image, that image is also converted into a vector. Then the database compares the query vector with stored vectors and finds the closest ones. The result: instant visual similarity search, powered by understanding, not keywords. Vector databases and AI models. Vector databases and AI models work hand in hand. The AI model, like OpenAI's embedding model or sentence transformers, does the job of converting raw data into embeddings, and the vector database stores and retrieves those embeddings efficiently. So the workflow looks like this. User input to the AI model then converts the input into a vector, then store the vector into the vector database. When the searches take place for similar vectors, the top results are sent back to AI model, which interprets and presents the response. This is exactly how RAG, Retrieval Augmented Generation systems work, combining large language models with vector databases to give accurate, contextual answers. Commonly used vector databases. Here are some of the most popular vector databases used today. Pinecone, fully managed cloud-native vector database built for AI applications. Weaviate, open source, highly extensible, and supports hybrid, vector plus keyword search. Milvus, high-performance open-source database for billion-scale vector search. FAISS, a library by Meta for similarity search often used inside custom systems. Chroma, lightweight and developer-friendly, commonly used with LLMs and RAG setups. Each of these tools serves a similar purpose: to make vector search fast, scalable, and intelligent. Let's talk about the use cases across industries using vector database. Now let's explore some real-life applications of vector databases that are used in our day-to-day businesses. First use case is AI chatbots. Instead of relying only on pre-trained model memory, chatbots can access vector databases containing relevant documents. When you ask a question, the bot fetches the most relevant content using semantic search and gives a factually correct contextual answer. The second use case is recommendation systems. E-commerce platforms and OTT apps use vector databases to recommend products or movies similar in style or genre to what users have previously liked. The third use case is image and video search. Platforms like Pinterest and YouTube use vector databases to identify visual similarities between media, even when tags or descriptions are missing. The fourth use case is fraud detection. Banks convert transaction behaviors into vectors. Abnormal patterns, vectors that don't fit usual clusters, are flagged as potential frauds. The fifth use case is healthcare. In medical imaging, vector embeddings help find similar patient scans or disease patterns, aiding faster diagnosis and research. The sixth, knowledge retrieval. Corporate teams use vector databases to store large internal knowledge bases, making it easy for employees to find the right information by meaning instead of exact keywords. I trust you got an idea about the vector database after discussing the use cases. There are thousands of such use cases we have in the real world. Now, time for us to understand the advantages of vector databases. Semantic understanding finds information that means the same even if the words differ. Speed and scalability handles millions or billions of vectors efficiently. Multimodal support works with text, image, audio, and video embeddings. Personalization helps tailor recommendations based on user preferences. Integration with AI fits naturally into modern AI pipelines like RAG, LLM apps, and recommendation engines. Now let's talk about the challenges and considerations. Even though vector databases are powerful, they come with their own challenges. 1. Storage and cost. Storing millions of high-dimensional vectors requires significant memory and infrastructure. 2. Model dependence. The quality of search depends heavily on how good your embedding model is. 3. Maintenance. Keeping vector data updated when underlying information changes can be complex. 4. Security and privacy, especially important when embedding sensitive business or personal data. The future of vector databases. As AI applications grow, from chatbots to self-driving cars, the demand for systems that understand context will rise sharply. Vector databases will become the core of all intelligent search systems, merging with traditional databases and graph databases to form hybrid intelligence layers. In the near future, we'll see multimodal vector search used for text, image, audio, and video in one place. Self-updating embeddings used for databases that auto-refresh based on new data. Tighter LLM integration can handle real-time reasoning powered by retrieval. In short, vector databases are not just tools, they are the memory engines of modern AI systems. We hope this gave you a solid introduction to vector databases. More videos are on the way in the coming days, so stay tuned and keep exploring with us. To summarize, a vector database is a modern data engine that stores and retrieves information based on meaning and similarity, not just exact matches. It's what allows AI systems to understand you better, to think in context, and to find the most relevant answers in a world overloaded with information. If traditional databases were the backbone of the digital age, then vector databases are the brain of the AI age. That wraps up our session on vector databases. I hope you found it insightful and easy to follow. We've got more exciting videos coming your way soon, so stay tuned and keep exploring. And hey, if you enjoyed this, please like the video and subscribe to my YouTube channel so you'll get notified whenever new content drops.